We've been working on OpenOffice Base, and this is part 4 of our exploration of the relational database system from Apache and OpenOffice, which is free to download and use, doesn't require internet connectivity, and is a great way to learn relational databases without having to buy anything. Last time, we created some joins in a query. Today we're going to use a more precise and flexible way of creating joins, and we're going to look a little at calculated fields. So what is a join? A join is when you have two tables that share a like column. So you could literally overlap the like column and have one table. And then if you query that one table, you're querying a larger amount of information, getting a much more customized result. But when you're not querying that joined table, the two tables live separately in the database. There's a good reason for this, because the tables may have separate topics, separate areas of concentration. The information in each table is more closely related to itself than to the information in the other table. And that means you can only open one table when you need to, and the other one can sleep. Prevents risks of transcription errors, minimizes draw on resources, and allows each table to get larger. That's all a little complex. What I mean is a query joining two tables gives you the flexibility of having two tables when you want them, and having one table when you want it. So what we did was, in the first time, we made a join between two tables on a common column. We just drew a little line with the mouse, found the two column names, and linked them together. That's a very simple way that works fine if you know what you're doing, if you know what you're looking for. But there's a better way to link tables, which is more robust. There's a new relation dialog box under the Insert menu in a query design, and that will allow you to pick the columns you need to match from a pick list. Very simple new relation dialog box. It has the ability to select which tables and which fields you want. First you select which tables you're looking at, then you select the fields. This is a close-up look of it. Because a join, you may have already selected tables, but you want to specify that with large queries you have many tables all side by side in your query selector. So you can't really draw lines. This will allow you to designate precisely which tables get the join. So we've selected two tables up top. In this instance, they're the only two tables in the query. Farm product and field, those are the two tables. We're going to skip over the type, use the default. And then below you have choosers for the columns. The farm product table, you select one of those columns. Field table, you select one of those columns, and the two of them match. And then you get an established join, just like if you drew a line. Then you design the rest of the query and run it, and you get a resulting query. So let's do an example of this. So we're going to open a new query in Base, create a query in Design View. First, of course, we select Farm Product Table and Field Table, just as we did before, and then close the chooser. And you can see we have the two fields, the two table lists of columns, and last time we drew a line between soil type, which was the join condition. This time we're going to go insert new relation, and since we've only selected two fields, those two fields appear. It doesn't matter how many tables you have that you're joining, you join them one at a time, so there's only going to be two tables in this chooser. Farm product and field are the two tables we have. We're going to skip over the type of join for now. And down here we have a chooser for the column that you want to join in both from both fields. In this instance, it's soil type again. We select soil type again. Then we hit OK, and a join is created. Irrigated for some reason is highlighted, doesn't matter. Soil type was what we chose on. So down here in the grid we're going to choose the fields we want. Farm product is the table, and farm product, i.e. the crop, is the column. Farm product is the table, and let's say soil type is the column. Now let's find a couple from field. Let's say the name of the field and the field manager. Let's use the shortcut. Like I said, the first row of the chooser will bring up tuples, or bring up pairs. Table column pairs to make things quicker. Excuse me with that, my headset. So we're going to select field manager. Make that display, and then we're going to hit the new query button, run query button. And there is our, as expected, our table. The only difference between what we did last time and this time is we used the field selector. So that's how we make a query using the insert relation or insert join chooser. Now, there are many different types of joins. Some of them get very complex. In this instance, OpenOffice has in the join selector the option to specify which type of join you want. They only provide a few. There are many more, but you can choose whichever join you want. We'll go through them. They return different combinations or different versions of the data in the joined tables. For example, imagine some columns are blank in one table, so you have some voids. Do you return those rows that have a blank space in the column you need, or a blank space in the column that you're joining on, for example? That's usually the case. If maybe you want to leave those out, or maybe you want to include all the rows, regardless of whether the joined columns have anything in them. These are called inner and outer, or right-hand join and left-hand join, depending on which table you're joining, or which table has the missing information. So a left join will return all information from the left table, even if it has no match in the right table. You'll notice the left-hand table is missing all the data except in the bottom 3 rows, except for farm product, which I think is probably a required field. So it can't really join on anything. It doesn't have anything in the soil type column to join condition to the other table. But even though it's blank, you just attach the other table anyway. Or you have a right join, which does the same thing backwards. If there's missing information in the first table, but adequate information in the second table, a right-hand join will return the stuff on the right-hand table. There's something called a full join too, which would do all of it. That's not available as a feature in this chooser. So let's look up close at the table as a reminder. The top row of the choosers has the tables involved, the 2 tables with which you're going to draw a relation. Then you select the type of join you want. Left, leave the natural option alone. That's more advanced and often fails. The nice thing is at the bottom, you have a definition of each type of join as you select it. Select the left join, this little definition pops up saying, left join contains all records from table farm product, but only records from table field where the values in the related fields are matching. Please note that some databases may not support this. So it will contain all records from farm product, including records missing information. That's a left join. Farm product is on the left in this instance. So left join provides the full table, including the voids, for the initial left-hand side table. And so you have a right-hand join, which is the same thing, except opposite, contains all records from table field, which is on the right, but only records from table farm product on the left, where values in related fields are matching. And then there's inner join, the first one in the upper left-hand corner, and also the default in the chooser, which will only return records, rows, fields, for which the contents of the related fields of both tables are identical. Meaning if there's any voids, it will not return them. It only returns records. Only returns records from fields where contents have no holes in them. And so again, left hand is all records where on the left, even if something's faulty on the left, it will return it. Okay, so let's talk about calculated fields. Just like in spreadsheets, if you do a mathematical operation between 2 columns in a query, you can take the result and then put it in another column. So if you perform 2 operations, if you perform an operation on 2 values or even 1 value in a record in 1 row or on one part of the row, you can get the result on another part of the row for every row. And we're going to do cost per acre over profit per acre because those are the only 2 numbers we have. And it's going to be a measure of profitability, just theoretically. And that value will appear for every row and its own separate column. What you do is you go down to the field chooser at the bottom of the query design screen, just like if you're selecting a column you want to display, and you select the table that the values to be operated on are in, and then you type in your calculation. In this instance, it's cost per acre divided by profit per acre. Each of the column names are in double quotes. You don't need an equal sign. It's very simple. way to just type in your division or subtraction or multiplication or whatever. And then you hit the query button, and a new column appears, which shows you precisely what the calculated value is in the table heading. And you see those numbers surrounded by red. Those are the returns. Only slight problem with this is they're integers, not very accurate. And this is a problem, of course. You want something more precise. And the problem is, the original data in the original tables was in integers. And even though you're dividing it, you cannot change the precision. Even though you're dividing two integers, the result may be a decimal point going into a couple of places. That won't reproduce. It will not provide you with more precision than the original values. So we have to go back to the original table and change the values from integer to float. Even if it's 0.00 in all the numbers as we do it, we will be able to derive more precision from them when we divide those integers. You can see here on the left we have the calculated field being entered, and in this instance we tried to go into the field format in the query and improve the precision of the number, but it didn't work. We selected a float with decimal places, but since the original information is integer, the result is still going to be numerals. Option 3 you see, where you actually have a calculated field whose result is in the decimal places. That's only happened after we went into the original table and changed the precision of the record. So let's do that now. Go to Table Design, Farm Product, using the Edit method. And instead of number numeric, I'm going to select Float. I'm going to save it. You see the original table values are still integers, but the computer knows that they are floats now. And the computer will, when it runs a query, treat them as floats, and the query will return decimal point with more precision. So the origin of the items, the origin of the two numbers is farm product. Cost, it was cost per acre in double quotes over profit per acre, and run the query. Ta-da! We have numeral. We don't have integer anymore. We have decimal place. I think in the original, the first one, we had a profit over cost because the numbers were larger. But in this particular case, it's much more important because the numbers are so small. Otherwise, with most of these values, you'd have 0. So again, what we did was we went back to the original table and changed the value type of the number. We changed the data type from plain number, which means integer, to float, which means it has 2 places beyond the decimal point, increasing the precision dramatically. So thank you for viewing. Today we used the join selector, also called the relationship selector, insert relationship. No more dragging lines to designate which columns are joined on tables. We gave a quick glimpse at what left, right, and inner join are. Left join will create a table which will include incomplete information that might be in the left hand table that you're joining. Right, the opposite, will include rows that have incomplete information in the right hand table. Inner join will only return data where all the information is complete in the row, or at least the information you're joining on is complete in the row. Then we did a calculated field. We generated a column of calculated values, a new column. We generated it in the query, and it's just two values enclosed in double quotes, separated by an arithmetic operator. And then we dealt with precision and increasing precision by going back to the original table, the original database table, and changing the precision value, changing the precision of the variable in the format chooser. And it created a query with a calculated field that had a much higher precision. So next time maybe we'll do a full project from beginning to end so we can see precisely how we can integrate all this information into something fundamentally useful. Thank you for viewing, and have a good day, and the next card for the next episode should be coming up now.